Today we're going to take a look at another aspect of simplifying rational expressions, when we have division of rational expressions. Now, division is a little bit more difficult than just simplifying or multiplication, which we just saw in the last video. But you know what? We'll find that this video will show us that dividing rational expressions, we need to do one more step than when we did multiplying rational expressions. So let's take a look at dividing some rational expressions. So let's say we have 5/8 divided by 1/2. What you learned back in elementary school and middle school is we can't divide fractions, but what we can do is rewrite things so it's multiplication. So we take our first number, 5/8, and instead of dividing by 1/2, we multiply by its reciprocal, or 2/1. And once we have this, we can use all the strategies we learned in the last video to simplify this rational expression. So 2 goes into 2 once, 2 goes into 8 4 times. So 5 times 1 is 5, and 4 times 1 is 4. So this little step here of changing a division problem into a multiplication problem is what we're going to do today. So let's take a look at the first problem. We have 8n squared divided by 4 divided by this fraction. So first thing I want to do is rewrite this so I have a multiplication of fractions. So 8n squared divided by 4 times the reciprocal of what you're dividing by. 10n divided by 8n. And now we're going to use our simplification skills. Anything that divides into either one of these two tops can divide into the two bottom, we can reduce. So I could divide the 4 into 8, but I like to do this 8 divided into 8. Just make my life a little bit easier. So the 8's cross out. Now, this n and n squared, because n is a factor in both of them, I can cross out one n here and cross out one n here, but I'm left with an n. So don't forget about that n. I also see I have a 4 and a 10. Well, 2 divides into 4 twice, and 2 divides into 10 5 times. So this looks a little bit messy, so I like to circle. I have an n up top, I got a 5 up top, I got an n up top. When I multiply those together, I get 5n squared. And the only thing left on the bottom is 2. That wasn't so bad. Just be very careful about crossing things out. So let's take a look at another one. Here, this is already factored out, but don't cross things out yet. We need to rewrite this division as a multiplication. So b plus 5 divided by b minus 4 times b plus 6. This division becomes times, and you flip this second fraction. 3b squared times b plus 6 is now in the numerator, divided by b plus 5. And again, my suggestion is this is just one big fraction if we multiply it. So now we can think of it as one fraction to reduce anything. So this b plus 5 factor here and this b plus 5 factor here can cross out. This b plus 6 factor and b plus 6 factor crosses out. You might want to cross out a b here with this b here, but remember, this b minus 4 is a complete factor, so unless you cross out the whole thing at once, you can't cross out part of it. So the final answer is 3b squared all over b minus 4. Oh, look at that. Change the colors. Oops. Let's take a look at our last problem down here. And just like before, we might have to go ahead and factor these. So when I look at this, I see a trinomial again. I need two numbers that multiply to give me -10 and add up to give me 9. I like to put my little work right next to it. So I would probably pick 10 and -1, which checks out. So this numerator is x plus 10 times x minus 1. Down here, I have two numbers. This is a trinomial again, and I need two numbers that multiply to give me 20, but add up to give me 12. I think I might try 10 and 2. So this denominator becomes x plus 10 and x plus 2. Now, division here. Now, here's what we can do. We can either factor these two now and then flip, or if you can do this in one step, that would be great. Change it to times and flip. So this now goes on top. So if I look at this factoring in the bottom, it's going to end up on top. Now, it's not a trinomial, but I see a common factor of 5x. If I factor out a 5x on the bottom, I'm left with x plus 2. And this factor on top is going to end up on the bottom. So I can also take out a 5x there, and I'm left with x minus 1. So this might be a tricky thing, but if you can factor and flip at the same time, that would be great. If you can't, then you can do either one first. It doesn't make a difference. You could factor the top and bottom first, and then do another step when you flip the division. Or you could flip this all at once, flip the division first, and then do the factoring. Either one doesn't matter. But now we see we have common factors on the top. I have an x plus 10 here and here. Those cross out. I have an x plus 2 here and here that cross out. I got an x minus 1 here and here. And guess what? I got a 5x here and here. So, what's left? Doesn't look like there's anything left on the top and the bottom, so that means 0, right? No. Remember, when you're reducing, you'll never end up with 0. When you reduce, when you're doing this crossing out, what you're truly left with is 1. So there should be a 1 here, a 1 here, 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 and here. Well, what happens if you multiply all these 1s together? You're left with 1 over 1. Well, what's 1 divided by 1? 1. This whole thing simplified down to 1. That's awesome! So, go ahead, take a look at some of those problems that you have to do, and see if you have anything that you need help with. Please don't forget to reach out to your teacher.